Welcome to Expert City. Please do subscribe, hit the like button and press the bell icon. So we are now going to talk about the Internet of Things. What are smart devices? These are usually devices that are not connected to the Internet. So we're talking about refrigerators, televisions, smartwatches, all those things. So for example, let's talk about a refrigerator that can order food for us automatically when we're running low on it. Wouldn't that be something? Now, what are embedded systems? As the definition goes, it's a combination of hardware and software to do a particular task. Now they can be a part of a system or operate as a single entity. Now what is IoT? It's an interconnected network of many nodes. Now each node can be television, an iPad, a phone, a camera, anything of the sort. So all our home automation is based on the principle of IoT. Now what are the generally used devices for IoT and home automation for beginners? We are looking at the Arduino, the Raspberry Pi, and certain other devices such as the TI Learner board. Now we're going to be concentrating on the Arduino because it is the simplest of all of them. So we're going to look at each part in the Arduino and understand the capabilities. This here is the USB jack. It's used not just for power, but also to get messages from the computer to the Arduino and the other way around. This acts as just a power source when the USB jack is disconnected from the computer. So for solo operations, this is where you'd probably be getting the power from. These are power rails, so when you're powering something external, say a sensor or an actuator, you send in power supply to those devices via these pins. The next is analog inputs. Now, signals are of two forms, analog and digital. Analog signals means they can take any intermediate values from the highest and the lowest points. Digital signals take binary values. Let's say in this case we have either a low, which is 0 volts, and high, which is 5 volts. Now it's to be noted that the Arduino can deal with analog inputs, but not analog outputs. The outputs are always digital, which is why you have something called a PWM, pulse width modulation, that's used to kind of mimic an analog signal. So although it's not true, that's how the result looks like. Now this is the main chip that handles everything. It's an Atmel Atmega based chip, and it's kind of like the brain of this entire system. So when you're looking at Arduino coding, there are certain keywords that you're looking for. The setup and the loop are the two main parts of the coding device. You also have a pin mode, digital read, and a digital write. Now we'll get to these in just a second. You also have an analog read function for the analog pins we just showed. So that is the basic, and we will start looking at codes where we use these individual terms. So let us try with the most basic program to blink an LED. What we have here is a very simple code for that. So as I told you, we have two separate parts of the code, a setup and a loop. Now inside the setup you have something called pin mode. So what you're doing is you're allocating LED built-in, which is basically pin number 13, and calling that as the output, because we have to declare whether pin 13 is being used as an input or an output. Now a setup is an initial case scenario. You just tell the device what everything is and then leave it as be. Now the loop, as the word suggests, keeps repeating itself. So you have digital write of LED built in, which is an indication for pin number 13, high, and then you're delaying it by 1000 seconds and then you're telling it to go low, which is 0 volts from 5 volts, and then you're delaying it by 1000 seconds, and then the loop goes again, so it would be high again for 1000 milliseconds, sorry, not seconds. And the thing to be noted here is, although this diagram shows the LED connected directly to the pins, you'd be better off using a resistor to reduce the current flowing through the LED, because most LEDs are limited to 20 milliamperes. Now we'll talk about common actuators, devices that generate outputs. So you have the LED, the most common of all of them. You have motors. You have an LCD based screens, you know, the ones used in displays in railway stations and airports. This is a piezoelectric buzzer used to generate sounds. And you have your regular speakers. And this is the most important component that you'll come up with, a relay. We'll talk more about it in the upcoming minutes. Common sensors used to detect what's happening around. Now, for an IoT device, it's very important for it to understand its environment, because most smart devices base themselves on the environment. For example, as the smart refrigerator example goes, you only order food when there is no food inside, so for that it has to sense the amount of food inside the refrigerator. Or when you take a smartwatch, it should indicate you when your heart rate goes out of control, or something like that. So you have your regular light-based resistor, okay, photoresistor, which changes its resistance value based upon the amount of light hitting its surface. You have an infrared sensor for motion, PIR, and then you have a proper infrared sensor for any application. This can be used to control devices like televisions as well, as a remote. You have a keypad, and you have ultrasonic sensors and hygrometers. The list just keeps going. Now, using sensors. So let us look at a very simple application without the internet, without any of the gimmicks. So we have here a night lamp. So the intensity of the light must increase as the light outside decreases. So here, instead of lamp, we're using an LED, and what we've declared is pin mode of A0, input. Now, as I've told you, the Arduino can deal with analog inputs. Now, as the resistance value changes, signal value keeps changing from 5 volts to 0 volts, and we need to note down the intermediate values. Right? So what we do is we declare A0 as the input. So if I can get a pen here, we've declared A0 as an input, and we've also declared pin number 9 as an output, which goes directly to the LED here. Now what we're doing is we're beginning something called serial communication. So what happens is, on your computer you'll have a little monitor called the serial monitor. It's denoted by a magnifying glass. If you click that, it explodes into a huge monitor that shows you serial communication. What this does is, when you say sensor value equals analog read of A0, so it reads the value that this gives. Now we know the basic equation as the resistance changes, so this is the voltage that comes into A0 here, and based upon that you print this value serial.println onto this little screen here, and then you analog write. Now, as I told you, there's something called a PWM. Now what this does is it mimics an analog output. So instead of having a signal that's 5 volts all the way along, what it does is it has it for 5 volts half the time, to 0 the other half, making it look like an average of 2.5 volts. So that mimicking we will come to in further videos, more advanced videos, but that is the basic idea. You change the amount of time it's on for and the amount of time it's off for to create the illusion of a lower voltage. And then you're just delaying it, giving it time to catch up. Now, as I told you earlier, it's better to have a resistor in place, otherwise this LED here might blow up. Moving on. Communication rates. Now, there are default values for communication rates. 9600 happens to be the rate for serial communication. Now, there are different rates for Bluetooth, there's another number, for Wi-Fi there's another number, it's a whole set of values. 38,400 for Bluetooth. So, baud numbers is the number of changes that happen to a signal in a given amount of time. Now, bit rate is the number of bits that you have. Let's say I have something like 10101. So what bit rate means is that let's say this happens in a duration of 1 second. So we're saying there are 5 bits in 1 second, so 5 bits per second would be the bit rate. Now, if I'm looking at baud, there's one change, second change, third change, and fourth change, which means 4 baud. Now, simulation softwares. When you're still a beginner, it wouldn't really make sense to buy all the equipment that you think you might need for the experiment, and you might want to first do it on a software which is cheaper and easier to do. So you write down your code on their scripting page and you just put in the devices the way you want them, make the connections on the software, and if it works there, you can always create your own hardware version. Now, I would advise you to go to Tinkercad because it's online and very easy to use. Of course, the other softwares can also be used based upon your convenience. And yeah, that's about it regarding the softwares. Now, as I told you, we're going to be talking about relays. Now, the Arduino cannot supply 15, 20, 30 volts, which is generally the norm for most devices. So for example, if you're looking at the night lamp example that we just did, if you really wanted to connect it to a lamp, these lamps deal with, based upon the country you're in, 200, 220 volts on a regular basis. Now that cannot be provided by the Arduino. So what we do is, we connect this to a relay. As shown in the diagram, a relay has 3 pins. Right here. So if you look at this circuit, there are 2 parts. There's one common wire represented by the C here, and one not connected, normally connected, and one normally open. So what this means is, from the common point here, if the wire is connected to a normally open, it means that unless you specifically send a signal or a code that says switch it on, the device is going to remain off, the circuit's going to remain cut. If, however, it was at normally connected, that would mean that unless you send a specific signal, the circuit is going to remain connected and the device will be on. So based upon your application, you have to make sure you choose the correct one that you want. Now on the other side, there are generally between 2 to 3 pins. Most relays that come out these days use 3 pins here, and one of them is the signal, one of them is 5 volts, and one of them is the ground. Now the arrangement of these may vary based upon the manufacturer, but these are generally the 3 pins that exist on this sugar cube relay. This here can be directly used to power much more powerful devices. Like if you look in the circuit that we have, the one right here, we have a mains plug coming in which is 200 to 220 volts based upon where you are, and that is connected directly to one of the bulbs that we use in our regular day lives. So that is connected to the normally open pin in this case. moving ahead. Communication protocols. You have many different communication protocols. We've already come across serial communication. You also have these things called UART, I2C, and SPI being the main forms of communication. Now we cannot go upon each one by one, but it's important for you to know that each device that we have, let's say a Bluetooth communication uses a particular protocol, Wi-Fi uses something different, so you need to make sure you understand the principles of this protocol and adhere to those guidelines before proceeding into that communication. Examples of wireless interaction. So for all your TVs, air conditioners, you have these remotes that are based on infrared sensors. You all know Bluetooth that we use for mobile devices, music and all of those, and Wi-Fi, your general internet. Now you also have mobile data, all of those which are different other forms of wireless interactions. 802.05. Now let's start with Bluetooth, simply because it's easier than Wi-Fi for us to understand. So 802.05 is the most commonly used Bluetooth interfacing device with the Arduino. Now you have to remember before you start any project that for an 802.05 the passcode is generally 4 zeros or a 1, 2, 3, 4. And another thing to remember is this follows a TX-RX system, which means if I get my pen out, you'll have TX on one side and RX on the other, and even on your Arduino you have a T and an R. T and R stands for the transmission and receiving. So what you have to remember in this protocol is that T goes to the opposite R. So one transmits while the other listens. That's the basic principle. Now proceeding, this is a very basic code for Bluetooth based LED control. So what do you have here? You have your serial communication here, and then you've declared 13 to be an output resistor, as I told you earlier, connected to an LED, and if serial dot available. This means that if there is an incoming message from Bluetooth device or something, what you do is you note down the value. Serial.read allows you to read the value that you have, and then you print the incoming value onto the screen, the display that I told you earlier. /n just means a new line, so that every value is printed on a new line. And if incoming value is 1 from the Bluetooth device, you make the LED high, otherwise you make the LED low. That's as simple as it goes. So what's happening here is you have an external device, say mobile device, and on your mobile you have a simple button, one for 1 and one for 0, and you can click either one of these and that will send an input directly to the 802.05. Now the 802.05 will send a message back right here, and what this will do is this will directly control based upon this part of the code. Now as we know, the initialization between the 802.05 and the Arduino is done from this area here. Serial begin 9600 and then serial.available. So it checks every loop whether there's something coming here, and then accordingly changes the status of this LED pin. As I've said, serial.available starts to search for any data that comes in from the 802.05 to the Arduino in this case. Once it finds some command, it acts accordingly. And the thing is, without this, there really is no IoT. Now, Node MCU. You generally tend to have several devices that simply just connect to the Arduino to give it additional Wi-Fi capabilities. So this is your Wi-Fi device and this is your Arduino, and you could directly just plug in something. Let's say one wire for input and one wire for output. It's generally more complicated than this, and you could use it as a Wi-Fi device, as a connection of devices, but an easier way to go about it would be to take the ESP8266 Node MCU module. That does both the functions together, so it's a combination of both of these, one simple package. Blink. Now, creating your own Wi-Fi code is very hard because there's a lot of protocols that you need to adhere to, as I told you earlier, and doing that will result in a lot of pages of code. You don't want to be doing that as a beginner. So what you can do is connect to the Blink app, and there's a simple library for you to download inside of the Arduino that allows you to link seamlessly to Blink. So all you have to do is, there's a thing called a button, slider, and so on, other simple devices that you can connect to from your phone and directly install it onto your Arduino device. Let's say you're using a Node MCU. You just set the Blink app to Node MCU and select the buttons that you want and give them the appropriate control. Let's say I say something like the first button links to the third output pin on the ESP8266, and that's it. So you're given 2,000 free energy credits to deal with. After that, you're going to have to start purchasing for more buttons or interfaces. Now, it's like a middleman. It does all the intermediate, low-level work. The problem with this, though, is that your control over what you do will be limited. Your creativity will be limited because this has only one set of features that you must use. You can't really use anything else if you're using this. Now, without Blink, your creativity, your inner creative talents tend to come out, but it gets very hard. Now, this is a main difference that you have to understand: an IP versus MAC address. Now, generally, every device that you have, your phone, your laptops, your smartwatches, anything, can have this thing called a network interface card. Now, what that is the end address. Each NIC, as it is called, has a particular MAC address associated with it. Now, that MAC address can be directly used as a physical address to indicate the endpoints of communication. Now, the IP address, on the other hand, is something generally used by routers to connect to the external world, right? So it's something like you have a router which connects to another router somewhere else globally, and they communicate via these specific IP addresses. Now, IP addresses have had multiple versions. We are in the transition between the 4th and the 6th versions. The only reason we transition is because the 4th version had a specific number of maximum devices that it could handle, and now there are way more devices on this planet. So we need to move to more numbers. That comes in IPv6. To make you understand this, let me say I have 4 blanks left. Alright, so you can have 1, 0, 1, 0, something of the sort. So in each case, you can have either a 0 or a 1, which means 2 per place. So 2 times 2 times 2 times 2. So we're talking 16. Now if it were only 3 instead of 4, it'd be 2 times 2 times 2, which would give you 8, or 2 cubed in other words. Here it's 2 power 4, and this number increases rapidly. So from IPv4, which is now in a shortage of numbers for each and every device, we've now moved on to IPv6, which has more numbers than we can possibly imagine. For the next 50 years, this will be sufficient. So once we get that, I there would not really be much of a difference between IP and the MAC address, but for now, we would be safe to assume that MAC address is the destination address of anything, while the IP address acts as an intermediary. So you have two main servers here, which communicate back and forth, which have a specific IP address. Now, IP address is again of two types, static and dynamic, but let's not get into that now. And each IP device is connected to a dynamically placed local device, each of which has a unique MAC address. So that's the basic idea. Now, without Blink, I will show you a very simple way of writing this code, the simplest it could possibly get. I will put this code up on the comment section so you can refer to it later. And using Arduino instead of Node MCU, I've already told you that a separate Wi-Fi module could be connected to your Arduino to use it instead of fixing on a completely new device like a Node MCU. This is the basic circuit to control a lamp using Wi-Fi. Now the basic idea is the same. You have a relay that is connected to a lamp in the normally open connection. So when you send a signal from your mobile device, this be your phone, and this sends a signal to the Arduino, and the Arduino in turn sends a signal to relay module, or you could bypass that by using a Node MCU in itself, which would directly do the communications itself. And yeah, that's about it. Thank you for watching.